Okay, folks, welcome to today's Advanced Space Concepts Laboratory Seminar. Today's speaker is Dr Iain Woodhouse from the University of Edinburgh. He's going to talk about Your Biosphere Needs You. So I'll pass over to Iain.
Okay, thanks, Malcolm. It's a great pleasure to be here to talk to a very different audience to what I'm used to. I am assuming that you're mostly all from a sort of technical instrumentation, physics, engineering kind of backgrounds. And I start off by saying that just because some of the slides that I'm going to tell you about are very much from the application side of things. My background is also in physics, and I'm going to touch a little bit on one or two physics aspects of that, but for the most part I'm going to talk more about the applications and where the work that I'm involved with in Edinburgh is using satellite technology in an Earth observation context. The title, of course, is a little bit of a false in the sense that satellites can't save the biosphere. Only people can save the biosphere. And so what I'm going to do, I'll go through quickly. Some of you will be more or less familiar with the carbon cycle, but I'm going to summarize some of the key issues of the carbon cycle and the terrestrial biosphere. And that's my particular expertise. That's where the biggest question marks are, and where many of the human activities of the modern world are influencing the biosphere and therefore the atmosphere most dramatically. And for that reason, I'll talk a little bit about REDD. Can I just check, actually, has anybody heard of REDD? Nobody's heard of REDD. Fantastic. And then I'm going to get into a little bit about the remote sensing directly of satellite remote sensing of the biosphere. And I'll show a few slides on SPECL, which is this mission concept that we're developing in collaboration with Malcolm McCollum here and a number of other groups around Scotland and Europe. And the European Space Agency has announced a call looking for new ideas for satellite missions. And this SPECL is the mission that we're going to see if we can come up with an idea that's going to work. And then finally, I'm going to talk a little bit about humans at a very, so from having gone from a global scale in the first slide, I'm going to go right down to a very local level in terms of a project I'm working on in Malawi, which is the connection between satellites and individual people working on the ground and having a livelihood based on the forest and the biosphere generally. Here's the carbon cycle. Do you have a pointer actually? Is there one on here? Excellent. So the green arrows are carbon dioxide coming out of the atmosphere, or carbon coming out of the atmosphere. The red arrows are carbon as carbon dioxide going back into the atmosphere. And most of you, I think, will be familiar with the fact that, well, forests, the biosphere photosynthesizes and therefore takes in carbon dioxide and emits oxygen in that process. But of course, it also respires. So there's actually a balance. The forests in the biosphere of the world are emitting carbon dioxide as well as taking carbon dioxide up. But the net effect, and the numbers here are in gigatons of carbon per year, the net effect is that there's an uptake of carbon into the biosphere. Carbon in the atmosphere, of course, is significant because it's a greenhouse gas. It has absorption lines in the thermal infrared and therefore absorbs the radiation coming from the Earth's surface as it warms up under solar illumination. And in fact, it's rising in the ballpark figure. I've used ballpark figures here just to help the addition in a minute, of about 3.5 gigatons a year. And that, of course, is correlated to what most people are at least aware of in terms of global warming. The oceans also have an uptake and a release of carbon dioxide with the atmosphere, and again a net effect of around about 2 gigatons per year absorbed into the oceans. Now that includes just the water itself and the chemical absorption of carbon dioxide. It also includes the biosphere and the oceans in terms of phytoplankton, which also photosynthesize. They take up carbon dioxide from the atmosphere and then die and sink to the bottom of the oceans. And that carbon accumulates over time to eventually produce the fossil fuels, which we now burn quite a lot of and add about 6.5 gigatons of carbon into the atmosphere as a consequence of fossil fuel burning. In fact, the activity of deforestation and changes in land use also contribute about 4 gigatons of carbon into the atmosphere every year. Now, you're all very numerate here, so you'll have worked out very quickly that there's a bit of an imbalance here, in that if you add 4 and 6.5 together, you get 10.5 gigatons a year going into the atmosphere. There's 2 gigatons taken out of the atmosphere by the oceans and 2 gigatons taken out of the atmosphere by the terrestrial biosphere. So you've got 6.5 left. The apparent accumulation of carbon in the atmosphere is 3.5. So there's 3 gigatons of carbon that's missing there. There's 3 gigatons that go into the atmosphere, almost as much as it's increasing. And that goes into the atmosphere every year. We don't know where it goes. It seems to it's taken up by something. And this is what's sometimes referred to as the missing sink. And that's a little bit of a worry, actually, because if you don't know where it's going, maybe it's in a mechanism that actually might switch off in the next decade or 2. And then all of a sudden your carbon accumulation in the atmosphere would double, just about. One of the theories of where that, or we're fairly sure that we understand the ocean connection here. So we fairly think it's the terrestrial biosphere which is contributing this missing sink, and it's doing something extra that we don't quite understand. One example of how that might be is that you could, the forests of the world, the biosphere of the world, actually grow better if you increase the amount of carbon dioxide. So this is carbon dioxide fertilization. Plants like carbon dioxide, so they grow a bit more, and if they're growing more, they're taking in more carbon. The problem with that is that that comes to a saturation point, where eventually you get enough carbon dioxide in the atmosphere that the fertilization effect doesn't work anymore, and it starts to level off. And that could happen within the next few decades. So it's very important that we actually understand what's happening on the terrestrial biosphere and understand this component here, because the deforestation and land use component is something which is actively done by humans. It's not a natural, or there is some forest fires which are a natural consequence of processes. But it's understanding this part of the balance here, and part of that is understanding relationships to deforestation and land use. And of course the thing is that satellites measuring globally in a very short space of time provides information that we'll see in a minute can actually feed into that understanding. Deforest, is that a big contribution in terms of the carbon dioxide that gets put into the atmosphere every year? In fact, in terms of global greenhouse gas contributions, that's what this diagram is here. It's about 17.5% as a consequence of deforestation and degradation of forests. So it's actually larger than the entire global transport system, for example. It's larger than all the land use in agriculture and sort of methane production from meat. So it's almost as much as the industry sector. So it's an enormous component of the humans' contribution to greenhouse gases. And in order, I did this slide recently for a seminar, and when I first did it, I didn't quite believe it, and I thought that can't be true. I'll have to go and check that, and I got a PhD student to check my numbers and everything. But this is what I'm going to show you just as a simple animation. This is a football pitch. Everybody knows what a football pitch roughly is like. So if you take a full-size football pitch, the rate of deforestation is in the world is this. So we could use a second to look at that and take into this is a representation, and it's actually a conservative representation of the loss of forest in the world. So in real time, that takes 2 seconds to remove that entire football pitch worth of forest, and that's happening all the time, day and night. So if you remember nothing from what I tell you today, remember that one slide and go away and bear that in mind, that that's happening all the time now.